Hello friends, we are going to learn concept of optimization from applications of derivative of the unit calculus of IBDP Math AAHL syllabus, and I have taken a problem from Math AAHL past paper. Now the problem here is consider the following diagram which shows the plan of part of a house. A narrow passageway with width 3/4 m is perpendicular to the room of width 6 m. There is corner at the point C here. Points A and B are variable points on the base of the wall such that A, C, B lie on straight line A, C and B here. L denote the length of AB in meters. So this is AB. Let alpha be the angle that AB makes with the room wall, where alpha lie between 0 and pi by 2 here. So this is the alpha angle here in diagram. A part show that L equals to 3/4 sec alpha plus 6 cosec alpha. B part 1, find dl upon d alpha. 2, when dl upon d alpha equal to 0, show that alpha equals to arctan 2. C part 1, find d2y upon d alpha square. C2, when alpha equals to arctan 2, show that d2l upon d alpha square equals to 45/4 root 5. D1, hence justify L is minimum when alpha equals to arctan 2. To determine this minimum value of L, two people need to carry a pole of length 11.25 meter from the passageway into the room. It must be carried horizontally. E part, determine whether this is possible, giving a reason for your answer. Now the solution. So first we have to show that L equals to 3/4 sec alpha plus 6 cosec alpha. We will be considering here the two triangles. So this angle will also be alpha. In a question it is mentioned that L denote the length AB. So we can write here L equals to AB equals to AC and CB. Now we will consider two triangles. One of the triangle would be A. Here we can assume any point here, say M. So A, C, M, and here we can assume the point here is N. So both are the right angle triangle. We will find out the value of CB and AC. So here AC would be because we know that this is 3 by 4 length, so AC would be 3 by 4 sec alpha, and in the another triangle CNB, CB equals to, we know this length is 6 here, so that would be 6 cosec alpha. Here we consider the triangle AMC, and here we consider the triangle CNB here. Now we will substitute the value. So 3 by 4 sec alpha plus 6 cosec alpha. So this is the solution of A part. Now we will proceed to B1 part here. In B1 part, we have to find dl upon d alpha equals to 3 upon 4. Sec alpha derivative would be sec alpha into tan alpha, and cosec alpha derivative would be minus 6 cosec alpha and cot alpha. So this is the solution of B1 part. Now for B2, dl upon d alpha equals to 0. So we can write here 6 cosec alpha into cot alpha equals to 3 by 4 sec alpha into tan alpha. We can simplify here. So 3 and 6 can cancel, so it will be 2. So here 2, we can write cos alpha upon sin square alpha equals to sin alpha upon 4 cos square alpha. Now we will cross multiply. So 8 cos cube alpha equals to sin cube alpha so 8 equals to 10 cube alpha, so 10 alpha equals to 2, therefore alpha equals to arc 10 2. So this is the solution of B2 part. Now we will proceed to C1. Here we have to find d2 L upon d alpha square So three by 4, we will apply the product rule. Sec alpha into sec square alpha, which is derivative of tan alpha, plus tan alpha, and sec alpha derivative would be sec alpha into tan alpha. Now the second term, minus 6. Again we will apply product rule. So cosec alpha into minus cosec square alpha plus cot alpha into cosec alpha, cot alpha, now we will simplify. 3 by 4 sec cube alpha plus 10 square alpha sec alpha plus cosec cube alpha plus 6 cot square alpha cosec alpha. We can open bracket here also. So 3 by 4 sec cube alpha plus 3 by 4 10 square alpha sec alpha plus 6 cosec cube alpha plus 6 cot square alpha cosec alpha. So this is the value of d2 L upon d alpha square. C2 alpha equals to arc tan 2. So tan alpha equals to 2. Now we will find out the value of tan alpha is 2. We will also use cot alpha. That value would be 1 upon 2 we know that this is alpha, this is 2, this is 1 root 5. So sec alpha would be root 5 and cosec alpha would be root 5 upon 2. Now we will substitute these values. d2l upon d alpha square equals to 3 by 4 sec alpha, so root 5 cube plus 3 upon 4 2 square into sec alpha root 5 plus 6 cosec cube root 5 upon 2 cube plus 6 1 upon 2 square into root 5 upon 2, that would be the value of cosec alpha. Now we will solve this. 3 by 4 root 5 can be written as 5 root 5 plus 3 by 4 into 4 into root 5 plus 6, so 5 root 5 upon 8 plus 6 upon 4 root 5 upon 2. Now further we will simplify. So 15 root 5 upon 4 plus 12 root 5 upon 4 plus 15 root 5 upon 4 plus 3 root 5 upon 4. So the answer would be 45 root 5 upon 4. So this is the solution of C2 part. Now we will proceed to D1 part. Here we need to justify that L is minimum at alpha equals to R tend to. So we can write, since d2L upon d alpha square, which is 45 root 5 upon 4, is greater than 0. Hence L is minimum at alpha equals to R 10 2. Now D2 part, we have to find the minimum length L. So L equals to 3/4 sec alpha plus 6 cosec alpha. We already having the value of sec alpha and cosec alpha. So 3/4, the sec alpha value is √5 plus 6 into cosec alpha value is √5/2. Therefore 15√5/4. So this is the solution of D2 part. Now we will proceed to E part here. Two people need to carry a pole of length 11.25 from the passageway into the room. It must be carried horizontally. Determine whether this is possible, giving a reason for your answer. So they are considering the length is 11.25 and we have the minimum length here is which is 15.5/4. So 11.25 is greater 15√5/4. So pole cannot be carried. So this is the solution of the given problem. I hope you understood the solution. Please like, share and subscribe this channel.